All right, we are on to Faraday's law of induction. So, Joseph Henry and Michael Faraday. Michael Faraday's an Englishman, so he's got to be darn smart. Both kind of discovered the law of induction at the same time. And basically, what they were experimenting was this little setup here. This little setup here, where you've got wires wrapped around an iron ring and a battery, and they thought that if they turn the battery on, or if they close the switch here, then this will create an electric current, which will create a magnetic field, which will go around to here and create an electric current over here. But what they discovered was that the only time that they read an electric current here was when they opened and closed the switch. And this is an important concept because of what it demonstrates is that only a changing, right down here, Faraday figured out that a changing magnetic field could produce a current on the other side, and he called this an induced current, right? Just like we had induced electric fields or in the electrostatics unit, it's an induced current, and it's only produced by a changing magnetic field. So why is this important? So it's important because you can induce a current in a wire by just moving it through a magnetic field. So let's say this is a wire right here. This is a wire. This is a wire, and there's no current. It's not attached to a battery or anything like that. It's just got electrons in it, and those electrons are just hanging out. But if I move it through a magnetic field, let's say I've got a big magnet here, South Pole, North Pole here. If I move it through the magnetic field, what it will do? It will induce the electrons in the wire to move. And as soon as you've got moving electrons, you've got electricity. So this is why Faraday's law of induction is fairly important. So again, you've got a wire, and it's not attached to anything. There's nothing forcing those electrons through. But if you move it through the magnetic field, they will move. Now, if you just stick it in the magnetic field, stationary, they won't move. But as long as it's moving, then the electrons in that will move. Or I could take a stationary wire and move a magnetic field around it, and it would cause those electrons to move. And here's an example. So using the following example, identify the direction of the induced electron flow current in this wire. So you're taking here's the wire. Ooh. Here's the wire, and you're just moving it down. So you're just taking a wire and you're just moving it down, and then you're moving it into the magnetic field. The magnetic field is into the board. So the way the hand rules work for this is your thumb points. If I've got this wire right here and I'm moving it down, which way are the electrons moving? They're moving down. So my thumb needs to point down, even though you say, well, it's a wire, the electrons have to move back and forth. That's not the way the rule works. The rule works, the electrons are moving. If I'm moving the wire down, then my thumb points down. If I'm moving the wire this way, then yes, my thumb would point that way. But I'm moving the wire down, so my thumb points down. My fingers point into the board, right? Into the board right here, into the board. So my fingers are into the board, and my thumb is down. And which way is my palm facing? It's pointing to the left. To the left. So in other words, as this wire goes down through this magnetic field, the electrons will be forced to the left in the wire. The answer to the question is left. All right, and just note how that's different from the left-hand rule, the way we applied the left-hand rule in the previous lesson. In this one, your thumb points towards which way the electrons are moving, and since the wire is not attached to anything, the electrons are just sitting stationary in there. So if I move this thing up, then the electrons are moving up. If I move it to the left, then they go in left, and so on. You get the point? And then your palm is going to point in the direction of the induced electron flow or current flow. Okay, so that's Faraday's law of induction, and again, that will help you finish this assignment. I think you should be able to do all of it now. We are going to go into Lenz's law, which is definitely one of the most fascinating and one of the most disappointing that I can't demonstrate this, because Lenz's law is so cool to demonstrate. But you, again, watch some videos, great videos on Lenz's law. We'll see ya in a minute.